Hi everybody. Today our lesson is about the application of integrals and specifically the volume. So to calculate the volume of solid generated by revolving a function around the x axis or y axis, we use method from integrals, specifically the disk method or washer method, which we will discuss today. So after today's class, you will be able to calculate the volume of any shape based on two methods. If the shape have like a hole inside it or no, if like for example this cylinder is full from this side but it's empty from this side, so this we will be using the washer method. However, if you have a shape like which is full like this and it is full, we will calculate the volume using the disk method. So the disk method is used when a region is revolved around the x-axis or the y-axis, creating a solid disk. Revolving around the x-axis, like if you have a function f of x, okay, and the volume v of the solid formed by revolving the function around the x-axis between a point A and the point B are given by this formula. So the formula is written here, and this formula actually came from the volume of any disk is p r square multiplied by the thickness of that disk. Okay, if you have, we call it T. So if you have a disk, suppose we have this disk like this, and it has this thickness, and the disk is full. So the formula of the volume that you all know is the pi times r square times the thickness. Okay, and this is your r, f of x is your r, so you will square it, and dx is the thickness of the disk, and you can see it from this image. So you will have your function, which have this shape. This is our f of x, and you have your radius, which is f of x. So if you have a point x here, okay, this is f of x, so you have f of x here. So and this f of x square times pi times the thickness of the disk. For example, if we take this disk, this is the thickness of the disk, and this is actually the x. Okay, so in this point you will have your x, your f of x, and you have dx. This is your dx. So the volume here is exactly this, from point A to point B. Okay, the integral from A to B of f of x square dx. And if you are revolving around the in this case we can call this as the x-axis, maybe like this. So now we are revolving around the x-axis. Okay, and if you are revolving around the y-axis, it will be the opposite, and here you are revolving around the y-axis like this, and it is same thing. It just instead of your dx you will have dy. Okay, so revolving around, I would just recap this. Revolving around the y-axis is you have to find your dy. You need to change your function from f of x to change it to f of y or g of y. okay, and you use it here. And we will do one example and you will see exactly this. Revolving around the x-axis, you keep your f of x as it is and you use this formula. Okay, so let's us do one example here. Like for this one, we are revolving around the x-axis. Okay, so the first thing we need to find, we need to have what is your function. So the first thing, our function will not change, so our function will be x squared. Okay, so the second thing you need to find is calculating the integral. We just said that the formula is pi times the integral from, we are revolving from between x is equal to 0 and x equal to 2. So from 0 to 2 of x squared, we need to square it and dx, which is equal to p times integral from 0 to 2 of x to the 4 dx, and you just calculate the integral here, which is x to 5 divided by 5 from 0 to 2, which will be p times x to, which is 2 to the power of 5 divided by 5 minus 0 to the power of 5 divided by 5, which is p times, I think, 32 over 5. Okay, but as long as you write this, your answer will be considered as correct. So the volume is p 2 to 5 over 5. Okay, perfect. So this is our volume. So we can use another example of revolving around the y-axis. You have to be careful. You need to know which axis you are revolving around. So same thing, our function is y is equal to x squared, but the first thing you need to change it from y to x. So we need to find your gx. So our function f of x is equal to x squared, but this is our y. But for me, I need to find x as what y. You need to find x as something of y. So in this case, what I have to do, I need to find x. So x is equal to the square root of y. Okay, so my function is the square root of y, which is equal to y over half. Okay, now we can calculate the integral. We are revolving from 0 to 4, so my integral will be from pi times 0 to 4 of what? Of y to the power of half square dy, which is equal to pi the integral from 0 to 4 of y dy, okay, which is pi times y square divided by 2 from 0 to 4. Okay, now we can calculate our integral, which is p times 4 square divided by 2 minus 0 square divided by 2, which is what? Which is 16 divided by 2, which is 8 pi. Okay, so the result is 8 pi. Okay, now let's us talk about the washer method. So this method is used as one extension of the disk method. So it is just same as the disk method that you have, but instead of this, you will have a hole inside. So you will have a hole inside, which will make it as washers. So revolving around the x-axis for a region between two curves. So imagine have a curve like this, okay, and another curve like this. So we have revolution between two curves. This one will rotate around the x-axis, and this one also will rotate around the x-axis, which will make us forming some washers. Okay, so you can see that our washer will be as this. So you have a full section here, and you have another full section here, which will be also full. So we are revolving around this axis. So for this is a curve, and this is another curve. So for a region between two curves, f of x and another one g of x, okay, is the outer curve minus the inner curve. In other words, the biggest radian minus the smallest radian, which we can see here. So the volume will be pi times the integral between a and b of the outer radian square minus the inner radian square, or the outer function square minus the inner function square times dx. Okay, and same thing if you are revolving around the y-axis, same thing, it just instead of x it will be y. We will see one example and you will understand this better. So imagine we have this example. Find the volume of a solid generated by revolving the area between the curve. We have the first curve f of x and another curve g of x. Okay, and is asking us the volume between 0 and 4. So between 0 and 4. So let me make this bigger so you can see what we are talking about. So this is our exercise. So this is our f of x is the square of x. So this is fx is equal to square of x, and this is g of x, which is x divided by 2. So we are asked to find the volume from 0 and 4. Okay, and this function, if it's revolving around the x-axis, it will give us this shape. Okay, and same thing for the other function, this function, if it's revolving around the x-axis, it will give us this shape. Okay, so we get with a solid which is have a hole inside it. So let me show you this actually in the real world, how it's look like. This is our solid, and this is our function square root of x, and this is our g of x is equal to x over 2. So if we rotate this, we can see it how it's look like. So you can see the perspective of the object. So we have some washers here. The blue section, the blue one here is the washer. So the washer start from 0 and go up to 4. So our washer is from 0 up to 4, and you can see we are actually just calculating the volume of each washer, and we do integral for everything. So this is the blue section is the section that we are interested in. Okay, and you can see our washer is moving from 0 up to 4. Okay, so let's us do the math to find our volume. The outer radius is what? Is f of x, which is square root of x. The inner function, which is x over 2. So the volume is pi times the integral from 0 to 4 of f of x, square root of x square minus x over 2 square dx. is equal to pi the integral of from 0 to 4 of x minus x squared over 4 d of x, which is equal to pi the integral from 0 to 4 to x minus pi the integral from 0 to 4 x squared over 4 dx, which is equal to pi times x squared over 2 from 0 to 4 minus pi times x cubed over 12 from 0 to 4. And this give us pi times 4 square over 2 minus 0 minus pi times x 4 to 3 divided by 12 minus 0. Okay, and you can just plug numbers and find the correct value. This will give us 8 pi over 3 if I did not make any mistake in my calculation. Perfect.